Assalamualaikum and greetings. My name is Kisinawafa binti Sharunizam, and my group decided to create a Newton-Raphson calculator using MATLAB App Designer. Our group members consist of 5 members, which is me, Kistina, Wahida, Azri, Kirana, and Ikmal. The provided MATLAB code defines a graphical user interface GUI application for performing the Newton-Raphson method to find roots of a given function. The application is built using MATLAB's App Designer and contains various components for user interaction, result display, and graphical visualization. For class definition and properties, the first one, class definition. The class Newton-Raphson app inherits from MATLAB Apps App Base, which is a base class for App Designer apps. Next, properties. The properties block declares public properties for the various UI components, such as the main figure window, tabs, panels, labels, edit fields, buttons, and axes. For callbacks that handle component events, the first one, we use fx edit field value change. This callback function is intended to handle events when the user changes the value of the function input field. Currently, it does not perform any operations. Second one, calculate button value change. This callback function is executed when the user clicks the calculate button. It performs the following step. First, it retrieves the function string, its derivative, and the initial guess from the corresponding input fields. Set tolerance toll and maximum iteration. Next, it will convert the input string to function handles for evaluation. It will then set up initial values for iteration, error, and storage for plotting the approximations. Next, it will run the Newton-Raphson algorithm until the error is below tolerance or the maximum number of iterations is reached. It also stores the approximation for plotting. After the Newton-Raphson iteration has stopped, it will then display the number of iterations and the approximate root in the corresponding output fields. Then, it will plot the function and the approximation on the axis. In summary, the Newton-Raphson app class creates a MATLAB App Designer GUI for performing and visualizing the Newton-Raphson method. The app allows users to input a function and its derivative, specify an initial guess, and calculate the root using the Newton-Raphson algorithm. The results are displayed in the GUI, and the function along with the approximations are plotted for visual analysis.
Here, I will show how to execute the code of Newton-Raphson. After run the code, it will display a MATLAB app of Newton-Raphson method calculator. So here is the question that user need to enter the input or question. Like example, we enter 3x power of 3 plus 2x minus 1. And then the derivative of the equation just now, which is 9x power of 2 plus 2. The initial value is 2. Then click calculate button and the result will be shown here. And after that, we can see the graph of Newton-Raphson method at analysis part.
Okay, so if we see from the first part, there is a code view and design view. So for the design view, it will appear Newton-Raphson method calculator. So there is two parts, which is a question part and answer part. So for the question part, there is a function, derivative, and initial values for x now, and calculate button. For the answer part, we have a number of iterations and the approximate root. So if we press the button of analysis, it will appear Newton-Raphson method. So here it will appear a function graph that has been given from the calculation part. And then if we go to the code view and then we run it, it will appear the same as we saw from the design view. So same, we saw the question part and then the answer part, and then if we press the analysis, it will appear the graph of the function we key in from the calculation part. Our Newton-Raphson calculator app offers several features that make it a valuable tool for users who need to find roots of equations quickly and efficiently. Here are the key features that potential users will appreciate. Firstly, root finding for equations. Our Newton-Raphson calculator efficiently computes roots of nonlinear equations using the Newton-Raphson method. Next, user-friendly interface. Our app is simple and intuitive user interface, which making it easy to input functions and initial guesses. Thirdly, graphical representation. Our Raphson calculator provides graphical plots of the function and its tangent lines, which it helps the users visualize the root finding process. Lastly, our Raphson calculator can be used as educational tool. It is suitable for educational purpose, helping students and educators understand the Raphson method through practical applications. The Newton-Raphson method is referred to as one of the most commonly used techniques for finding the roots of given equations. It can be efficiently generalized to find solutions to a system of equations. The Newton-Raphson method's impressive speed, adaptability, and precision present compelling arguments for its applications across a spectrum of disciplines, from environmental engineering to economics. Its applications span across various fields of industry due to its efficiency and effectiveness. Here's some applications that have been used in industrial applications. Firstly, engineering. Engineers regularly confront systems and equations that require exact solutions. The Newton-Raphson method provides an efficient way of estimating roots in electrical and control engineering, mechanical system designs, and geotechnical engineering. In the field of physics, the Newton-Raphson method forms the basis of various algorithms used to solve equations representing physical properties and behaviors. This includes applications within quantum mechanics and fluid dynamics. Thirdly, economics and statistics. Economists exploit this method to estimate parameters in econometric models, where identifying the maximum likelihood involves solving some equations iteratively. Similarly, in statistics, it used to find roots in regression analysis and nonlinear least square methodologies. Lastly, environmental science. The Newton-Raphson method is routinely used in environmental modeling, especially for handling nonlinearity in the relationship between various environmental factors. This includes prediction models for air pollution, water quality, and climate change.
With that, that is the end of our video. Thank you.